Energy exists in many forms. For example, thermal energy, chemical energy, electrical energy, and so on. Today's focus will be on electrical energy. Electric energy refers to energy which has been converted from electrical potential energy. When we talk about powering appliances in our home, we focus on the rate of energy use, specifically how much energy per unit time the appliance draws. Measuring our energy use is important to find ways to prevent wasting energy. In this particular formula, power equals change in energy over change in time. Power is measured in watts. Energy is measured in joules. And lastly, time is measured in seconds. If we want to use this formula in any type of question, or if you want to calculate anything, we must make sure all the values are in these particular units. So power must be in watts, energy must be in joules, and time must be in seconds. Today we will be calculating the use of energy, specific calculations for finding energy, so we can rearrange the formula to energy equals power times time. Sample question is quite simple. A compact fluorescent light bulb operates with 7.0 watts of power. Calculate the energy needed to provide light for 24 hours. Answer in joules. So we want to start off by writing the given values. So the power equals 7.0 watts. We know that it must provide light for 24 hours. So the time is 24 hours. And we know that the required value is energy in joules. So it's an unknown value in joules. We know that in the formula we want power in watts, so that's good. However, we want time in seconds, and it's currently 24 hours, so we want to convert that to seconds. So how we do this is by figuring out how many seconds are in an hour, and that's 3,600 seconds. So we can cross out the hours, and we can calculate 24 times 3,600 in the calculator. And after calculating this, we will get 86,400 seconds. So now we have watts and we have seconds, so we can input these two values in the formula. We know we want to find energy, and energy equals power times time. Since we have the values in the correct units, we can input the values into the formula, and we get 7.0 watts times 86,400 seconds. So next we need to put this into the calculator. 86,400 times 7.0 watts, and we get 604,800 joules. Looking back at the question, we can see that the lowest number of significant digits are 2, so we want the final answer in 2. If we rewrote this as 600,000, we would know that we have one significant digit, but we want 2. So we have to write it in scientific notation. Placing the decimal place here, we can count 1, 2, 3, 4, 5. So it's 6.0 times 10 to the power of 5 joules. So we always know that we want to end off by writing the answer of the question in a sentence. So therefore, the CFL bulb would require 6.0 times 10 to the power of 5 joules in order to provide light for 24 hours. So there you have the first question. Keeping in mind that household energy is measured in kilowatt hours, this type of question deals with that calculation. You are studying for an upcoming test in your bedroom. You decide to get a snack to give you energy. When leaving your room, you forget to turn off the lamp, which has a 100-watt light bulb in it. You return from the kitchen 23 minutes later. how much energy did you waste in kilowatt hours? So again, we want to start with writing down our givens. We know that the light bulb has a power of 100 watts, and we know that it was left on for 23 minutes. We know that we want to find the energy in kilowatt hours. So looking at these values, we want power in watts, so that's already correct. However, we want time in seconds. This obviously must be converted, so 23 minutes over 1, and then we want to make it into seconds, so there are 60 seconds in 1 minute. So 23 times 60 lets us know that there are 1380 seconds in 23 minutes. So now that we have power in watts and seconds for time, we know that those are the correct units, so we can move on to the formula of energy equals power times time. We can input the values of 100 watts for power and 1380 seconds for time. Entering this in our calculator, we find that the total number of joules used by the light bulb during that time period was 138,000 joules. Looking at the question, we want energy in kilowatt hours. So to do this, we must use a conversion. You have to keep in mind that in 1 kilowatt hour there are 3.6 million joules. So using these values, we can do 138,000 in a calculator divided by 3.6 million joules. And we find that the total number of kilowatt hours are equal to 0.038333333 kilowatt hours. However, looking at the question, we see that the least number of significant digits are between 2 and 1. So obviously 1 is less than 2, so the final answer has to be in 1 significant digit. If we rounded this, the 8 would round up, so there would be 0.04 kilowatt hours. So therefore we can write the conclusion statement of 0.04 kilowatt hours of energy was wasted. So now that we are done this question, if you may want to use 0.04 kilowatt hours to calculate maybe your bill or in general how much energy wasted. So that concludes this tutorial. Hopefully you learned a lot about how to calculate energy using power and time, and thank you for watching.